We have two people, Adityan and Kundavai. Now Adityan says that the velocity of a nearby tree is 0. Kundavai looks at the same tree and says, no, it's moving at 25 meters per second. Today we are going to talk about relative velocity. So Adityan is standing by a tree and he happens to have measuring instruments with which he can measure the position, displacement, velocity or the acceleration of any object. Now he uses these instruments and claims proudly that the velocity of the tree is 0. At the same time, he claims that Kundavai, who happens to be in a train, is moving at 25 meters per second eastward. So, let's call this the tree, and Adityan is standing out here, and from his point of view, Kundavai's train is moving eastward at 25 meters per second. So, he claims that her velocity is 25 I cap because he is using this coordinate system, x-axis pointing eastward and y-axis pointing north. Kundavai, who happens to be sitting inside the train, is also carrying measuring instruments, and from her point of view, the train is not moving. It's the tracks, the trees, the electrical poles, all of them are moving in the opposite direction, and as far as she is concerned, the velocity of the tree near Adityan is minus 25 I cap. So, from Adityan's point of view, let us call the train's velocity u, which happens to be 25 I cap. And from Kundavai's point of view, the tree's velocity is minus 25 I cap. Now, to say it in scientific language, we say that in Adityan's frame of reference, the tree's velocity is 0 and Kundavai's velocity is 25 I cap. In Kundavai's frame of reference, the velocity of the train is 0. The velocity of the tree is minus 25 I cap. What is the real velocity of the tree? Now, many people will say, no, trees and buildings do not move, so the real velocity is 0. And because Kundavai is moving at 25 I cap, things appear to be moving at minus 25 I cap to her, so the apparent velocity of the tree in her frame is minus 25 I cap. So they will claim that the real velocity is 0, but the apparent velocity is minus 25 I cap. But pause for 1 second and think about this. In the reference frame of the sun, the tree and the earth, they're all moving at 29 kilometers per second around the sun. So wouldn't that be the real velocity of the tree? So now you're beginning to realize that maybe there is no such thing as a real velocity, and velocity is always relative to a reference frame. So, in the sun's reference frame, the velocity of the tree is 29 kilometers per second in some direction. In Adityan's frame of reference, it is 0. And in Kundavai's frame of reference, it's minus 25 I cap. So, velocity is always relative to a certain frame of reference. But that still leaves the question whether, of all these infinite frames of reference, maybe some frames are superior in the sense that the velocities and accelerations that we measure in those frames are in some sense the real values. Now this question we are going to examine in another video. Today in this video, all we are going to do is find out if the velocity of an object in one frame is so much, what is its velocity in another frame. As an example, let's look at a bird. Adityan looks at the bird and says the velocity of the bird is this vector v. Kundavai looks at the bird and says, nope, the velocity of the bird is some other vector v prime. Our job is now to find v prime. Now that's very easy. Let's start with the tree. Adityan says the tree's velocity is 0. From Kundavai's point of view, she adds a minus u vector to it so that she gets minus 25 I cap. So essentially, to every velocity that Adityan measures, Kundavai adds a minus u vector to get the velocity that is seen in her frame of reference. So, if Adityan says the velocity of the bird is v, Kundavai will see that it is v minus u. This is the transformation equation that we are seeking. So, we can write this equation in this form also. V is equal to v prime plus u. Let's give these two frames names. Let's call Adityan's frame the stationary frame. Now, Adityan's frame is not really stationary. After all, we saw that from the sun's point of view, Adityan's frame is moving at 29 kilometers per second. We just call it stationary. Just give it a name. Similarly, Kundavai's frame, let's call it the moving frame. Of course, from her point of view, it's not moving. It's Adityan's frame that is moving at minus 25 I cap. We're just giving them names. So, this equation tells us if the velocity of the bird is v prime in the moving frame and the moving frame itself is moving at velocity u, then the velocity in the stationary frame is the vector sum of the two. Let's do that. So, if you look at this equation, we saw that Adityan claims that the velocity of the bird is, you see, this vector here. So, let's draw that here. That is the velocity of the bird as seen in Adityan's frame. To that, we have to add minus u. So let's go ahead and add a minus u vector. If I add that, the resultant is this vector. This is the velocity of the bird as seen by Kundavai from her train. So this is v prime. Compared to any velocity that Adityan measures, Kundavai sees an extra minus u added to it. This is the simple vector velocity transformation equation. Here's Kundavai's train, and in Adityan's frame of reference, it's moving with a velocity of 25 I cap, which we call u. So u is the velocity of the moving frame as measured in the stationary frame. Inside the train, now there is a boy that rolls a ball with a speed of 5 meters per second in the forward direction. Now you have to understand that from Kundavai's point of view, the train is not going anywhere. It's a stationary train. And inside this stationary train, the ball is rolling at 5 meters per second eastward. Of course, from her point of view, the rest of the world, trees, buildings, rivers, railway tracks, etc., they're all moving with a velocity of minus 25 I cap. That is westward. As far as she is concerned, she is in a train that is not moving. Now, the velocity v prime that she sees of the ball is 5 I cap. Now the question is, what is the velocity that Adityan sees? According to our equation, v is equal to v prime plus u. So that becomes v prime is 5 I cap plus u is 25 I cap, and that gives us 30 I cap. So Adityan sees the ball moving at 30 meters per second. Now there is a very intuitive way to see this. I'll show you how that works. Here is the train. At one instant of time, when the ball is here, 1 second later, the train is here, and the train has moved 25 meters during that 1 second. And during this 1 second, the ball has moved 5 meters inside the train to this point inside the train, which has moved here. So the ball is now here. So that This distance is 5 meters. So seen from Adityan's point of view, the ball has moved from here to here, 25 plus 5, 30 meters in 1 second. So this was easy. So you might say, we went to all this trouble to memorize this equation, v is equal to v prime plus u, just to get this silly result. But where it becomes interesting is when you realize that this is a vector equation. And when we have different directions, it becomes very interesting. Let's check that out. This time, the boy rolls the ball in a direction northward at 5 meters per second. So as far as Kundavai is concerned, the ball starts at this wall and ends up at that wall. During that time, of course, the train has moved. So from Adityan's point of view, the velocity of the ball is v prime, which is 5j cap. Remember, this is our y direction and this is our positive x direction. So 5j cap plus 25I cap. This is the velocity of the ball that Adityan sees. Let's draw this vector. This is going to be 5j cap plus 25I cap. So the vector is going to be this. So from Adityan's point of view, the ball moves from here to there. And that's not surprising because during the 1 second, the train has arrived here. Now, what is the speed of the ball as seen by Adityan? The speed of the ball is square root of 5 squared plus 25 squared, and that's going to be 25 plus 625, root of 650 meters per second. That's the speed of the ball in Adityan's frame of reference. So when you tell me that the velocity of a certain object is 30j cap plus 40I cap or whatever, you have to tell me in which reference frame you're talking. If it's in Kundavai's reference frame, or is it in Adityan's reference frame, or is it in the sun's reference frame? Each one is a completely different velocity. So unless you tell me the frame of reference, velocity by itself makes no sense. Velocity is always relative to some frame of reference. Normally, when we say buildings and trees have zero velocity, we assume that it's a ground frame of reference. We don't state it, but that's a hidden assumption. Okay, so I'm going to stop the video here, and the proof of this equation, this great equation, v is equal to v prime plus u, will be given in another video. And in the next video, we are going to apply this equation to rain and umbrella problems. And in the video after that, we'll do river and boat problems. We are going to have a small playlist of videos under the heading of relative velocity and relative acceleration. Goodbye for now. Ciao.